In this video, we're going to continue our work in section 2.3, and we're going to look at example 2 in our notes. So for example 2, we're asked to find the equation of the line tangent to the graph of f of x equals x squared at x equals 3. So I just want to draw a quick sketch for us to have a visual of what we are computing here. So f of x equals x squared. We've seen that before. So that curve is just a nice, beautiful parabola. Like this. And now we want to find the equation of the line tangent to the graph of f of x equals x squared at x equals 3. So if we look at a point when x equals 3 here, and we look at what that tangent line would be, we can draw it in. We want to know not just the slope of this tangent line or the derivative, we want to know the equation of this tangent line. So if we use notation of x and y, what we want to find out here is the y equals mx plus b equation of that line, the equation of that line. And so what we need to find is the m and the b. So the m, the slope of that tangent line, that's going to be the derivative, which we've computed before. So that would be f prime of 3. So we need to find f prime of 3. And then we need to find that intercept b. So first things first, let's go ahead and find f prime of 3. So to do that, we need to consult our limit definition of the derivative, and that's back up here. So we're going to set up that difference quotient and compute a limit. So for us, that's going to be the limit as h goes to 0 of f of, we can just use 3 here in place of x, in this definition. So we have f of 3 plus h minus f of 3 all over h. So using our function x squared, f of 3 plus h is 3 plus h squared minus 3 squared all over h. And again, we're taking the limit as h goes to 0. So we want to make sure we include that limit as h goes to 0 on each step until we've evaluated the limit. So this becomes the limit as h goes to 0 of 3 squared plus 6h plus h squared minus 3 squared all over h. And so I just FOILed or expanded that 3 plus h squared out, but feel free to pause the video to expand it for yourself. All right, so now we want to see what we can simplify here. And you'll notice that we have a 3 squared and a 3, we're adding a 3 squared and we're subtracting a 3 squared. So those 3 squareds cancel very nicely for us. So we have the limit as h goes to 0 of 6h plus h squared all over h. Which you'll notice that the numerator, we can factor out an h. So we have the limit as h goes to 0 of h times 6 plus h all over h. And lovely, those h's cancel. So now we just have the limit as h goes to 0 of 6 plus h. So now we can just evaluate this limit by plugging h equals 0. So this just becomes 6 plus 0, which is 6. So now there we have our slope of our tangent line. So our tangent line will look like the following equation. We'll have y equals 6x plus b. But we still need to find b. So is there any other information we know about our tangent line? Do we know any point on our tangent line? We know that the point when x is 3 and the output is f of x, or f of 3, is on our tangent line. So what is that point? 3 comma f of 3. Well, we know what f is. F is x squared. So the point on our tangent line is 3 comma 3 squared, or 3 comma 9. So we can use this bit that we just found out, that structure of our tangent line, and this point of our tangent line to find b. So let's go through that together. So we know that the point 3 and 9 is on our tangent line. So I'm going to plug in 9 for y and 3 for x. So I have 9 equals 6 times 3 plus b. And now I have an equation with just one unknown, b. So expanding this further, I have 9 equals 6 times 3, which is 18, plus b. So I can subtract 18 from both sides, and I get 9 equals b. Actually, negative 9, right? Positive 9 minus 18. So we know b is equal to negative 9. So now let's put these two bits of information together. Our slope is 6. Our y-intercept is negative 9. So in final, our equation of our tangent line is y equals 6x minus 9. And that is the equation of the line tangent to the curve f of x equals x squared at x equals 3.